This is the first question. In which of the following process heat is neither absorbed nor released by the system? So this is nothing but the definition of adiabatic process. In adiabatic process, change in heat energy is equal to zero, which means heat is neither absorbed or nor released by the system. So for this question, option B is correct answer. So in adiabatic process, change in heat energy is zero, and in that particular process, heat is neither absorbed nor released by the system. Now the second question, increase in temperature of a gas filled in a conductor would lead to increase in its mass. So if we increase the temperature, nothing will happen to the mass and increases its kinetic energy. It's possible since the kinetic energy of the gas is given by half kBT, where K is the Boltzmann constant and T is the temperature. So if I increase the temperature, automatically kinetic energy of the gas will get increased. So increase in temperature will lead to increase in its kinetic energy. And the third question, the total energy of an electron in an atom in an orbit is minus 3.4 electron volt. Its kinetic energy and potential energies are. So they have given a total energy which is equal to minus 3.4 electron volt. They are asking what is kinetic energy and potential energy. So we know kinetic energy is equal to minus of total energy, negative of total energy. So here this kinetic energy is equal to minus of minus 3.4 electron volt, which is equal to 3.4 electron volt. And potential energy, we know it is 2 times of total energy. Potential energy of an electron is equal to 2 times of total energy. So here what is the total energy? Minus 3.4. So 2 into minus 3.4, which is equal to minus 6.8 electron volt. So my kinetic energy is 3.4 electron volt, whereas my potential energy is minus 6.8 electron volt. So corresponding to this, we have option 3. And the fourth question, a circuit is given, the correct expression represented by the circuit. Which of the following Boolean expression is suitable for this given circuit? So this is the question. How to check these things? It's a simple one. All we need to do is we need to observe the circuit. Let's take a combination of A and B. And let this be the output. So if A is open, it is 0. If B is also open, then 0. So first what I am going to do is I am going to open both the gates or both the keys. That's why I have put 0 0. And if I open A and B, then observe no current will flow here. Since it is an open circuit, so nothing will flow. Every current will flow in this way. So the LED will glow. If it glows, then I have to put 1, which means output is available. And in the second combination, I am going to close this B and open this A. 0 1. Now also it is an open circuit, so no current will flow in this circuit. Every current will flow through the LED. Output 1. And in the third case, I am going to close this B and I am going to open this B and close this A. So B is kept open and A is closed. Now also it is an open circuit, so no current will flow and every current will flow through the LED. So output is equal to 1. And finally I am going to close both the gates. Both are 1. I am going to close both the gates or both the keys. So here 1 and here also 1. Now the current will flow through this path. It won't flow through this path. I tell you why. Because here the resistance is very low, but here we are having some resistance. We are having no resistance. In this path there is no resistance, so the current will always prefer a path which has low resistance. That's why in the final case current will flow in this path. No current will flow through the LED. The LED won't glow. So here 0. So when both the keys are open 0 0, no current will flow through this path. LED will glow. When A is kept open and B is closed, then also LED will glow. And when A is closed and B is kept open, LED will glow. When both the keys are closed, LED will not glow. And look at the expression, or look at the truth table. You will understand it is nothing but the truth table of NAND gate. So my output is equal to A and B bar, which is nothing but NAND operation. So this circuit represent NAND operation.